Welcome to this series on indeterminate forms and L'Hopital's rule. In this series, you will learn everything about L'Hopital's rule in a clear and simple way. What it is, when it can be used, how to use it properly, and most importantly, the cases where the rule does not work. And to keep everything simple, we'll just divide the topic into 3 to 4 short, easy to follow videos. And we will begin this series with indeterminate forms, the part which is most oftenly skipped. Why are some limit forms guilty of being indeterminate while others are innocent? At the beginning of this series, we will investigate the crime scene. At first, we have 0 over 0 form. What we are trying to find, we have a limit of a ratios where we have two functions f and g, and we want to know where this ratio goes when our independent variable goes to some number a. And what is the first type of limit? We just plug in the value of x as a. When you put a here, you get f as 0 and g as 0. This is an indeterminate form. Directly you can't say what is this limit. And shortly we will know why this is an indeterminate form. See, if top is going to 0 and bottom is some happy little stuff other than 0, then this is a determinate form and this will go to 0. Your 0 will dominate no matter what number you have. If top is going smaller and smaller to 0 and bottom is going to some finite number, then their ratio will certainly go to 0. This is determinate, this is fixed. And if you have some happy little stuff on top and 0 in bottom, your bottom is going to 0 and in top you have some finite number other than 0, then this is also a determinant form and this will go to infinity depending on the sign of 0, in which side you are approaching 0, in positive or negative. If negative, then this will be negative infinity, and if positive, it will be positive infinity. So here this 0 dominates and here this 0 dominates. And when you have these two big players come together, then this becomes an indeterminate form. It's like when two big players come together, when they were dominating in their respective market, and when they come together they just fight and the result is unknown. It can be anything between minus infinity to infinity or minus infinity, or the limit may oscillate wildly. This can be anything. This is indeterminate. Next we have infinity over infinity form. This is also an indeterminate form. Same, we have a ratio of two functions and we want to find its limit when our independent variable goes to some number a. And when you plug in the value of x as a, you are obtaining infinity in top, infinity in bottom also. And here this limit you can't find directly. This is an indeterminate form. And here also we will see, if top is going to infinity and bottom is going to any number, any finite number, here it can be 0 also, this infinity will dominate and this ratio will go to infinity. It's a determinant form. And if we have some happy little stuff on top and infinity in bottom, and here this infinity will also dominate and it will pull the ratio to 0. So if you have any ratio which is in this form, some finite number over infinity, then that is a determinant form and that will go to 0. This infinity where it dominates on top and this infinity where it dominates on bottom, and they come together, this is an indeterminate form. Next we have 0 times infinity. This is also an indeterminate form. Here you have product of two functions and one is going to 0, another is going to infinity. This is an indeterminate form. See, if any of these function goes to 0 and other goes to some happy little stuff, any finite number, this is a determinant form and this will go to 0. And if you have any stuff and another is going to infinity, then this will be infinity. And if 0 and infinity they come together, then there is a fight. Then the answer is unknown. This is a indeterminate form. This depends on function, and who will own, that is unknown. Next you have infinity minus infinity form. There is a difference between two functions, and we want to know where this difference goes when our independent variable goes to some number. And if this goes to infinity, this goes to infinity, then this is an indeterminate form. We don't know where this difference will go. Here also we can see infinity minus any stuff. This stuff can be any number, that is a determinant form, and it will go to infinity. And if you have any happy little stuff minus infinity, this is a finite number, and this will also go to negative infinity. This is a determinant form. These two are determinant forms. And if you have those two big players come together, then this is indeterminate. Next we have infinity to the power 0 form. This is also an indeterminate form. Here you have power fx to the power some function gx. When our f goes to infinity and g goes to some stuff, and if stuff is a positive quantity, then this is a determinant form, and this will certainly go to infinity. And if you have your happy little stuff is negative, then this is also an indeterminate form, and this will go to 0. This is also a determinant form, and this will go to 0. And if you have some stuff and g goes to 0, here this quantity goes to some finite number which is not equals to 0, then this is going to infinity, this will go to 1. But if you have those two big players infinity and 0, they come together, and who will own, this is unknown. This is an indeterminate form. Next we have 1 to the power infinity form, an indeterminate form. And here also you have powers fx to the power gx, and this f goes to 1 when x goes to a, and g goes to infinity. See, usually when we have 1 to the power stuff, when f goes to, this function goes to 1 and power goes to some number, some finite number, usually this goes to 1. This is a determinate form. Certainly you know this is going to 1. And if you have, say, this is a real number line, and this is 0, this is 1. If you have some stuff from here, if you have some stuff, and this is infinity, here your stuff is between 0 and 1, and this will go to 0 for sure, for certainly. This is a determinant form. And if you have a stuff from here, then that stuff to the power infinity goes to infinity. Here you have stuff between 0 and 1, here your stuff is between 1 and infinity. And if they come together, here infinity dominates, here this 1 dominates, and when they come together, this is indeterminate. At last we have 0 to the power 0 form. This is our 7 number. Here also we have powers. We have limit x goes to some number, we have f to the power g. See, if you have some stuff, usually if the stuff is non-zero and g goes to 0, this is going to some finite number other than 0, and g goes to 0, then this is a determinant form and it will go to 1. And if you have 0 to the power some stuff where stuff is positive, then certainly this will go to 0. This is also a determinant form. If stuff is positive, this will go to 0. If stuff is negative, then it depends on the f, where f goes, from which side it approaches 0. If this is 0 from positive side, and here you have some negative number, then this will go to positive infinity. And if you have here, this is a negative side and it goes to 0, and then this will go to negative infinity. And when these two big pairs are 0 and 0, they come together. This is indeterminate. So this is it. And here we know how the borderline becomes indeterminate when you have this side determinant, that side determinant, and the bridge between them is indeterminate. You don't know the limit, and that depends on the functions, and we will apply some rule, some method to find this limit.